Right, we move on to another subsection, go trigonometry, esibiza ngokuthi reduction formulae. Nechaza igama reduction, we're going to reduce a big angle into a small angle, preferably an acute angle, preferably a special angle. That's another topic. Reduction formulae. Right. It helps to have a Cartesian plane when we're dealing with this section. Remember, these are the x-axis, these are the y-axis. Now, when we move this way, we usually move towards the positive angles. When we move that way, we're moving in the negative direction. So anti-clockwise is positive and clockwise is negative angles. Remember that angles are measured in degrees. Right, let's move on. So this angle is 0 degrees. So I've not moved an inch. Once I move, it's something. So I'll come to this one, which is a right angle there. It will be 90 degrees. I move to an obtuse angle. Remember the types of angles. This one is 180 degrees, which is a straight line. From there, I move to this reflex angle here, which is 270, and I go back to 360 degrees. The revolution, I revolved one rev there, which is 360 degrees. Now, what is the reduction formula says? Whenever we've got an angle which is acute, remember the acute angles are usually in the first quadrant. So an acute angle will be here when we're dealing with reduction formulae. Or we say 90 degrees, you go back. So it's going to be 90 degrees minus theta. So this is how you reduce in the first quadrant. In the second quadrant, remember, second quadrant is above 90. So it is 90 degrees plus theta. I'm going this side. But if I'm coming from here, I'm going back. So this can also represent it as 180 minus theta. The third quadrant, I can either call it 180 degrees plus theta because I'm moving into the third quadrant, or from here I go back, or 270 degrees minus theta. The fourth quadrant, how do I represent the fourth quadrant? It can be 360 degrees. What? It is minus, I'm going back, I'm going to this quadrant, the fourth quadrant, 360 minus theta, or 270, I'm going forward, 270 plus theta. Once you have this, you've got all your quadrants, the 4 quadrants. Remember, this is the cast diagram. We've got these trig ratios. There are 6, all of them. There are 6. We've got sine theta, cosine theta, and tan theta, and they are reciprocals. Now, whenever we talk about the first quadrant, if the angle is in the first quadrant, whether it is sine, cosine, or tangent, they're all going to be positive. So all ratios are positive in the first quadrant. In the second quadrant, it is on sine and its reciprocal. So sine, no cosec, or positive for second quadrant. Remember, in second quadrant, the angle is pay 190, but less than 180. All those angles, they say they're in the second quadrant, and if that is the sign, it will be positive. So we say all students take Coke. So all ratios are positive here. Only sine and its reciprocal is positive here. Only tan and its reciprocal is positive here. Only cos and its reciprocal is positive here. Others, they call this the cast diagram, C-A-S-T, cast. Others, they just say all students take Coke. Others, they just say all stops to Chatsworth. It depends on your taste. You can use whatever you want to use to remember that. All students take coffee or whatever they take. Right. This is what we call reduction formulae. All right, let's move on. So what is this saying to us? For example, if I've got sine 120, where is sine 120? It is in this quadrant. Remember, when we reduce this, when we do this, we usually prefer to that these angles that we subtract, or the reference angles that we subtract, should generally be a special angle. It brings us to another topic of special angles. What are special angles? Special angles are angles that we can calculate without using a calculator. In your trigonometry, you'll find question general that will say, prove a look ngaphandle ukusebenzisa calculator. So makuthiwa usebenzisa calculator, usebenzisani, you just use the special angles, What are special angles? They are special because we can work with them without using a calculator. For example, in this Cartesian plane, 0 is a special angle, 90 is a special angle, 180 is a special angle, as well as 270 is a special angle. Now, how do you find those angles without using a calculator? For example, if I have a circle like this one, Now this is my Cartesian plane. I know here, if this is A, this is B, this is C, this is D. Suppose a circle has a radius of 5 units. Let's say this circle that I have here has a radius of 5 units. Remember what a radius is. It is the distance from the center of a circle to the circumference. So this distance from here to here, we call it a radius. The distance from here to there, it's a radius. From here to there, radius. From here to here, it's a radius. It is the distance. A radius is the same, whether I'm taking it from here to here or from there to there. It's the radius. A distance is always positive. So when I'm asked, remember this is a radius of 5 units. It simply means that from here to here, it's 5. From here to B is 5. From here to here is 5. From here to, so the radius anywhere in the circle is 5. It will never be minus 5. It is a distance. If I'm moving from here to town, it's 10 kilometers. Even when I come back from town to this place, it is 10 kilometers. I'm not going to say it's negative 10 kilometers because I'm moving in the opposite direction. So when I move from here to here, the distance is 5, and from here to here, the distance is still 5. It's not going to be negative. But we know that these x's this side are negative. Let's look at the coordinate geometry now. If I've got this radius is 5 units, so what are the coordinates of point A? In other words, what is the value of x here and what is the value of y here? X, of course, it will be 5. Y, there is no y here. We write y is here, we write x is there. Or x bapalala, or y is bapalala. So mangibuza y la, akekho y la, akekho y la, akekho y. Mangibuza x la is 0. X la is 0, into angekho 0. So what is the value of y at this point? It is 0. But what is the radius here? What is r? From here to here, the radius is 5. If I ask you the radius there, what will the radius be at point B? It will be 5. What is the radius here? It is 5. What is the radius here? It's 5. The radius here is 5. Anywhere in the circle, the radius is 5. It doesn't change. But come back here to point B. I know that the distance from here to there is 5 units. If I'm asking you the coordinates of this point, of point B, what is x at this point? X ababhalwa la. So intengekho 0. Uba no y la. Y distance is lapha, which is 5 units. But ubani radius la. R is 5. I know that R is 5 here. Let's look at this point here. What are the coordinates of C? What is the value of x here at this point? The value of x, it's negative now. It is negative 5 is to 0. And the radius is 5. It doesn't change. Now, what does this have to do with our special angles? It will cater for angles like 0, 90, 180, 270 without using a calculator. For example, when I'm looking for sine 0, when we say sine 0, where do I go? I go to here because 0 la. When I say sine 90, I will go there because this is 90. Sine 180, it's there. Sine 270 is here. Sine 360 is here. Let us use sine 0, for example. What is sine 0? Sine 0 degrees. Where is 0? 0 is here. So what is sine? What is the definition of sine? Sine. Sine is y over r. So this becomes important. Sine is y over r. So sine is y over r. I go to 0 and check what is y, what is r there. This is where 0 is. What is y? So opposite. What is y here? Y is equal to 0. What is r here? What is r? R is 5 over 5. 5 goes how many times into 0? It doesn't go. So I know that sine 0 degrees is 0. I can use it without using a calculator. You can take your calculator, we check it, you'll get the very same answer. If I ask you what is sine 90, you go there to 90 degrees and look what is y there, what is r here. If I'm looking for 180, I go there. I mean for 180, 270, I go there, 360, I go back there. That's how you treat these angles: 0, 90, 180, and 270, and back to 360. So you go to that particular angle we are talking about. Right. I'm still on special angle. I want us to look at this one quickly. On special angles also. These are not the only special angles. Remember, I said the special angles. Let me just give you all the special angles. It is 0. These are special angles. Angles that we can find without using a calculator. These are called special angles. All of them together. The smallest is 0, followed by 30 degrees, followed by 45 degrees, followed by 60 degrees, followed by 90 degrees, followed by 180 degrees, 270 degrees, back to 360 degrees. All these are special angles. But this circle that I have here caters for 0, 90, 180, 270, and 360. So caters for 0, 90, 180, 270, and 360. What about those three? What about 30, 45, and 60? We do have triangles to explain those. We use these triangles to explain these three. For example, if I've got maybe 30 degrees there, I've got 60 here, I've got 90 here. Remember, this is a triangle. What is the sum of interior angles of a triangle? It is 360. So, not 360, 180. If I add this one, and this one, it should give us 180. The sum of interior angles of a triangle are supplementary, 180 degrees. So 60 plus 30, it's 90, plus another 90, it is 180 degrees. So the sum of interior angles of a triangle are supplementary. The other one, the other diagram that I will use is this one. So in other words, this one caters for 30 and 60. What about 45? If this is 45 degrees, this is 90 degrees, what is this one going to be? Yes, it is 45 degrees. So 45 plus 90, it gives us 180. No matter what type of triangle you have, if you add the three interior angles, you must get 180 degrees. Now, I know here I've got to have 1, 2, and square root of 3. But the challenge is, where do I put those? I've got 1, 2, and square root 3 in this side here. Remember, this is the hypotenuse. It is the longest side. It is the longest side. All right. You've got to find the way to play around with this. If I look at this one, I see the number 3. So next to where you see the number 3, that's where you put the square root of 3. 3 here. Then I'm left with 2. I'm left with 1 and 2. Remember, these numbers are not the same. 1 is not the same as 2. Which one is big? Obviously, 2 is big. So which one is the bigger side here? This is the bigger side. So you put a bigger value there and a smaller value there. That's how you find you find this one. So in other words, when you say sine 60, what is sine? So opposite over hypotenuse. So you can definitely see what is sine 60 degrees. Sine 60 is so opposite. It's root 3 over 2. That's how you find it without using a calculator. You've got your answer there. You can leave it in such form, in that form. Right. Let's come to that other one. I've got 45. I usually find this easier this way. It helps me to remember these dimensions for these three. It's important that you must have them, because in trig, we usually look for those distances as well. Now, without using a calculator, when I hide here, I see a particular number there. Do you see the number there? It is 45. How many 45 do I see when I'm hiding this side? I only see 145. So that distance, I remember it in that way. If I hide this other side, I'm looking for the side now. Do I see a number there? Yes, I see a 45. How many 45s do I see? I only see 1. I write 1. This is how I remember it. You can find your own way to play around with this. Let's look at this side now. If I hide it in this one, I see a particular number. How many times do I see 45 there? 2. That's why I put square root 2. That's how I remember it. Remember, I hide this side, I see a 145. I put it this side, I see another 1. If I hide it this way, I will see 2 of them. Then I put a square root over there. That's how I remember that part. So how do I use this one? If I'm looking for sine 45, so opposite over hypotenuse. So sine 45 will definitely be 1 over square root of 2. That is what we call special angles. Thank you.